So, can you guess what this all about? I hope many of you may have heard about the term shaping or forming process, or about rolling, forging or extrusion. If not, let me explain you in brief. But before that, let me introduce myself. Hello everyone, I am Adarsh Kumar, pursuing BTech in Marine Engineering from Tolani Maritime Institute, and I am here to present on the topic material processing. Introduction. Material processing is defined as the series of steps or unit operation used in manufacture of raw materials into finished goods. The operation involves a succession of industrial processes with various mechanical or chemical procedures, usually produced in large quantities or batches. The alteration of materials by hand has existed since the beginning of civilization and was transformed by the introduction of automation equipment in the 18th century. The basic machinery developed during the Industrial Revolution was primarily used for the cutting and formation of products. Process engineering technology, method, and equipment have evolved dramatically since then and continue to improve in quality, capability, and production yields. Now, let us come to the types of material processing. The processes used for the manufacturing of desired product generally provide two major functions. The formation or alteration of material. The formation of parts or product is usually achieved by molding, casting, or the application of pressure. The physical state or the composition of commodities and the product can be altered by a number of different means, including chemical, mechanical, and thermal operation. As we all know, chemical engineering methods are applied in order to modify the cellular structure or molecular properties of material on a microscopic level, right? And in thermal processes involving the addition or reduction of heat are used to alter a range of materials, especially metals. Mechanical operation employ the use of specialization equipments in the transformation of solid matter. Additional processing includes bonding, cutting, and finishing may be required for the provision of finished products. The two pictures shown here are the examples of casting. Now, these processes can be applied to a variety of materials and the applications are including adhesive and sealants, agriculture chemical, biomaterials, ceramic, composite, electrical materials, glass, metal and alloys, nanomaterials, paint, ink and coating, personal care products, pharmaceuticals, plastic and polymers. The pictures are given here for your reference. Now, let us take the example of a steel plant. The raw materials required to manufacture steel are coal, iron ore, and limestone. The three raw materials used in making pig iron, which is the raw material required to make steel, are processed iron ore, coke, and limestone, that is CaCO3, or burnt lime, that is CaO, which are added to the blast furnace at an interval, making the process continuous. The limestone or burnt lime is used as a fluxing material that forms a slag on the top of the liquid metal. This has an oxidizing effect on the liquid metal underneath, which helps to remove impurities. Approximately 2 tons of ore, 1 ton of coke, and a half ton of limestone are required to produce 1 ton of iron. The steel can be further converted into different forms, that is slab, billet, and bloom. The slab can be converted into further different forms, that is plate and hot roll or cold rolled. The billet can be converted into hot rod bars, rods, and tube rods. And the bloom can be converted into structural shapes or racks. Stainless steel plant in steel industry are equipped with the additional production facility. Nickel and chrome are added to the steel to produce stainless steel product. For example, these are used in kitchen appliances, medical equipment, exterior walls, and roof of the building. The sheet steel is used to manufacture the body of the cars and automobiles. Now, let us come to safety, which is the most prior in every industry. So, what is process safety? Process safety is a disciplined framework for managing the integrity of operating system and process handling of hazardous substances by applying good design principle, engineering, and operating practices. So what is process safety and what does it do? Basically, it deals with the prevention and control of incidents that have the potential to release hazardous material or energy. Such incidents can cause toxic effect, fire, or explosion and could ultimately result in serious injury, property damage, loss of production, and environmental impact. Here, as we can see in these two images, they both in both images we can see that the workers are working in proper PPE, which is actually a very good practice. Now, let us come to the conclusion. The goal of material processing is to develop the structural feature, example crystal structure, microstructure, size and shape, needed for the product to perform well in its intended application. Material processing is central to the field of material science and engineering and is a vital step in manufacturing. The conversion of starting material to the final product occur in three steps: preparation of starting material, processing operation, and post-processing operation. The processing operation can be divided into five categories based on the state of matter most important to the process, that is melt, solid, powder, dispersion or solution, and vapor. Metal and ceramic and polymers are formed by operation in each of the categories so that the common scientific and engineering principle can be understood and applied to various types of materials. Now, I shall conclude my presentation. Thank you for giving me this opportunity.